So glad to welcome all of you. It's very, very exciting times. I hope all of you are using all kinds of LLMs in your daily life, getting exciting results as well as becoming more efficient. Now, the challenge is that how do we fine tune your LLMs for your specific task and how efficiently, how speedily you can actually do your work. And that's where I think a new revolution is starting on small language models. And we are so excited actually to listen to the whole the gamut of opportunities which is opening with small language models. RP is here. He will also do a small demo of this of this SLMs and its power. But we wish that learning has to be a continuous process. It is not just this 1 hour webinar that we want you to be part of this, the whole learning process, that we want you to go through further and then practice whatever has been today we discussed. We have been hosting webinars and just to create awareness about the technology and its amazing potential that it is offering. So I would come back again with some of the curated questions. So the format is going to be that RP will do about an hour or less than an hour and take a few questions. So please use chat or Q&A. That too, you can post your queries. We are online. We are on live on YouTube as well. Please do share if your friends are interested. And we will come back with, after curating the questions, we'll come back again and discuss about what next, right? So this is just a exciting starting of your understanding on LLMs as well as SLMs. Thank you so much, RP. Looking forward to an exciting session.
Thank you. I hope folks you can hear me, see me. Okay, so like Rupa and Dr. Shinu mentioned, today's topic is the small language model. And I'm sure everybody has been bitten by the bug of the large language models, and you're using that in some shape and form, either using the web UI, UX, like a Chat GPT or Gemini, or you're doing it via the API. So we wanted to shift gears a little bit, and not everything which is big is better for you. So that's where the small language models really come in, and we'll talk about where exactly you should or should not be using the small language models, and what are the comparison between them, right? And we'll talk about what is a generative AI for people who are new to this topic. So we'll set some context, but I will go through those slides very, very quickly, and then I will start hands-on demo, and this will take some time to download for most of you. Depending on your computers, you may be able to download or you may not be able to do that. So I'll just talk about that, give you maybe 10 minutes while I'm addressing your questions. So that's going to be the flow, and I will let you know when exactly is the time for you to start downloading and sending your questions. So we'll use that in parallel, right? Okay, so let's begin with a quick introduction of the generative AI, right? So the generative AI, as the name suggests, is a particular branch of AI which is focused on generating things. It is focused on generating images, text, audio, video, music, and the list goes on and on. So the type of AI which is used for generating new content is what we broadly refer as a generative AI, right? And you can see there's a lot of applications around us, right? So you have Stable Diffusion, which basically helps you generate the images. You have Chat GPT or Gemini or Llama that can help you generate multimodal sort of thing. Multimodal meaning they can help you generate anything you want, right? So there is a new version of Chat GPT which has come in. It's called Chat GPT 4.0. O signifies omni. Basically, you can do pretty much everything that you can imagine using that particular LLM, right? And a quick view of the generative AI and the conventional AI. So I'm sure a lot of you would have done some bit of conventional AI in the past, or if you haven't done on your own, you must be at least familiar with in terms of what is artificial intelligence, machine learning, deep learning, some of those things, right? So this is a comparative view of that, just to refresh everyone's memory on that. So conventional AI focuses on making predictions or enabling the human decision making, right? So for example, I may have a model which helps me figure out whether this particular customer is likely to default on the loan or not, right? or this particular treatment is going to work for a particular type of disease or not, right? So those are the things where you see everything is AI has been used for many decades now. If you contrast that with the generative AI, like I said, I mean, it's not necessarily predicting anything. It's not necessarily, saying, you should do or should not do this. I mean, but it basically creates things for you, right? So it's something which never existed in this world is something that it will be creating, right? And the closest thing that you can imagine in terms of the generative AI is when you're having dreams, right? Um, you can be imagining things that have never happened in your life, or you may be imagining things which are connected to certain incidents or experiences, both good or bad in your life. And based on that, you're actually dreaming of certain things. But you will see that your human brain is capable of generating new things, right? Brand new sort of imageries, situations, people you are meeting, all of that. And that's basically precisely the generative AI, right? So it has gone through the large amount of training data in terms of the historical data which exists, and basis that it is now in a position to create something which is brand new, right? And I think there are questions, whether this is really new or this is copyrighted information, or there might be, some sort of legal issues in using the LLMs and whatnot. We'll talk about that later on, but we'll pretend that everything which is being generated is fairly new, right? And that's the case, I think, in my view. It The learning approach, it basically uses the supervised and supervised historical data and all of that. The generative AI is trained on internet of data, right? So it doesn't necessarily say, okay, I'm gonna do supervised or unsupervised. It basically uses an approach which is called fill in the blanks or the masking technique, right? So for example, you will say you expose the models to a large amount of data, and then you uh, you know blank out certain things, and you basically have the model predict what is going to be the next word. And the model does it right based on the human in the loop training or supervised training and all of that. And then once the model knows, what is the next word, then you can say next sentence. Once it knows next sentence, then you can say next paragraph. And that's how basically it really learns that behavior. Uh, you know, just some other things. It is conventional AI is great at routine task when you know exactly what data you're going to get and what output you really require. Generative AI is when you really want to get very creative. And limitations for the conventional AI, as the name suggests, is not going to be able to generate things, versus generative AI can really generate. And the flip side of that is really like the computational and the data that is being used in the model training. It may have certain biases, certain languages which you may not be comfortable in terms of using that in your day-to-day world or the corporate setting. So there are some challenges with respect to that. Also, there is a big challenge in terms of hallucination, right? Like human brain hallucinate, imagine things which are not there, right? So the large language models can also have that, which is very difficult for us to really tell, whether that is true or not, because we're just relying blindly on that information, right? And I have listed out some examples. So this is a picture, and I think I do have a link over here where you can go and play with this information here. So the link is right here. So lifearchitect.ai and some of the data, and you can download this data in the raw format as well. It gives you a quick pictorial view of the journey of the LLM in the last several years, so basically more than a decade, starting with that 2020. And you can see we started with some of the very tiny models like a GPT-2 or BERT, right? BERT is not even visible; it's that small. And then over a period of time, the number of parameters continue to go higher and higher and higher. And then you can see a wide variety of players coming in. Pretty much all the tech companies have their own model as of now. And there are a lot of companies which came in on the scene only because of the large language models, something like, or somebody like OpenAI, for example, right? Or Anthropic. These are the companies which are known only because of their LLMs that they have built. So the main takeaway from this is that there are a variety of different large language models. There are variety of different small language models, which are basically denoted by the small bubbles that you're looking at. The number of parameters continue to grow exponentially, and they are following what we call as a Moore's law in semiconductor industry, which is basically every couple of years or every 18 months, the number of components in a unit area will double. Similarly, the number of parameters the models are packing now are also growing exponentially, right? So that's what we are looking at, and there's no signs of slowing down. And if you think that we have the best model that we can imagine, probably somebody is working on a model which is going to even beat your best model as of now. So that is the speed that we're looking at, and the things around us are moving quite rapidly. Same data, but represented in terms of the number of parameters, and I will talk about the parameters. Parameters are basically nothing but you can imagine the amount of intelligence that that model is packing. And higher the number of parameter, generally speaking, more intelligent the model, right? And technically speaking, for people who know the deep learning models, parameters are basically nothing but a combination of the weights and biases in training that model. And those are the different layers, interconnected layers, and what weights and biases we will have. So that's what basically it has, right? And I have a much more simpler view of the parameter as well, which I will talk about that, right? So these are the learnable weights and connection inside the model. This gives you a sense of the scale and the complexity of the model, right? Higher the number of parameters, higher the capacity of the model, higher the knowledge the model is carrying with us. And generally speaking, that's a good sign. Now let's come to the LLMs training part, and that will help you in terms of setting the stage for the small language model as well, and how you can fine tune and train that. So basically, like I said, they have been trained on the data which is available on the internet, right? So for example, your Wikipedia has been used, your news websites have been used, right? Somebody's blog has been scraped and used. So it's basically a massive amount of training that has gone in creating these LLMs, and we know that there is all sort of information available on the internet, right? Some of the information is correct, some of the information is propaganda or completely false, right? So all of that has been comprehended by these models, and that's where a lot of these tech companies are very, very apprehensive of taking the LLMs live and giving it to the public, because all the biases, all the bad data out there has been figured in. Now, over a period of time, what they have done is they have controlled that behavior via some sort of curated data, specifying certain guardrails while training the model and all of that. But still, there are situations where the model may say certain things which are not appropriate for a particular audience, right? So, for example, if I'm not going to bring up that example, but if you go to huggingface.com and try either the BERT or digital BERT, and you can say she worked as, right? And automatically it will come back and say she worked as a waitress, right? Or as a nurse. And then you just take it out and erase that and then put he worked as, and he worked as a pilot, as a doctor. So that's the bias that I'm talking about, right? So some of the models may still demonstrate that gender bias or race bias or religion or the political affiliation, right? Or many, many other things that we typically human go through in our life cycle. So that's what basically the models have been trained on. Now, from the higher level training, you can see, the models can be customized to do a variety of different things. So for example, if you train on text, it will be great for question answering. Similarly for sentiment analysis, right? If you train on images, it will be great for image captioning because it understands the images, right? It will be great at object recognition and so on and so forth. If you train on speech, the model will be great in terms of your instruction following, the verbal command like a Siri or the any of the interfaces that we typically work with, right? Where you can actually speak your words and the model is able to comprehend and give it back to you in the same language that you are having, right? Or the translation, for example, the massive amount of information which goes in the text, in the speech, can be used to understand different accent of the people. So for example, Indian accent may be different from the North American accent, right? And similarly, the North American accent could be very different from Australian accent, but we all mean the same thing. So all of that information is captured in the speech along with the text information which is coming in. And you can see, the model will be generally fine-tuned and trained to do one activity. So for example, there might be a model which is great at text question and answering, right? Which is the instruction model or instruct model, as you call it. There could be another model which is great at images, But then there are these massive models, the one that I was talking about earlier, which is ChatGPT 4.0, for example, or even Google Gemini, right, or Claude from Anthropic, right. So some of these models can do all of this and other things which are not listed out over here. So that's basically the way you train a model. So going back, you have this massive amount of information. So the model is actually pointed to it and asked to learn a variety of different things, and then you can fine tune the model performance to do one particular activity, whether it's a question answering, sentiment analysis, image captioning, and so on and so forth. Now, it's very, very easy to say how the models are trained, but this is a very, very expensive process. It takes months and years of data and training process. It takes a lot of compute, millions of dollars, a huge carbon footprint in terms of training of these models, and a lot of different things which go in making these models work. Like, I'm not even talking about the people who are training and working on these things. I'm just saying in terms of the actual physical hardware and the other monetary aspects that we're looking at. Very, very expensive process. So it's not like that you and me can get up one fine morning and say, I'm going to build my own large language model. Right? You just don't have the compute to make it happen. You need, very, very big GPUs. You need to have massive amount of data. You need to store that data somewhere, and many, many other things in between. This is a quick view, slightly technical, but don't worry, even if you're not able to get it right now. So once you start experimenting with the LLMs, these things will become second nature to you. So this is how the accuracy of the model is defined. And this is true for both large language models and the small language models, right? So you get an off-the-shelf model, which is called a foundational model, right? So for example, if all I do is, let's say I connect my Python code to the ChatGPT API and start using that for doing certain Q&A, for doing image generation, for doing variety of different things. That's what we call as a foundational model. And the foundational model, like I said, are a generic model. They're general purpose model. They're not fine-tuned for your own data, for answering the question in the way that you want them to answer, right? And there are many, many other things which the foundational models will not get right. And they are hence the bottom of the pyramid in terms of the accuracy. So they're the least accurate. When I say least accurate, don't think that everything that they're gonna say are gonna be wrong. It's just like, you can make them better over a period of time. The second thing you can do to make the model's performance better and in line with your expectations and the needs and the desire of you or your company is what we call as a prompt engineering. And some of you may have already heard about that. This is a brand new job category which is coming in the AI world, which is, we want prompt engineers, right? And it sounds very simple that all you're doing is just typing the English prompt and getting the model to follow your prompt, right? But it's very, very difficult to execute. So you need to really understand the inner workings of the model. You need to understand, how do I give a clear structured direction? You need to understand how to generate the output in the right format, for example, JSON or CSV or text. You need to understand how to get that output to the desired shape and form that your clients are really requiring from you, and variety of different things. So that's the second level of accuracy. So you start with the foundational model, you can do your prompt engineering, you can make it better. Now, if you want to make it even more better, what we can do is what we call as a retrieval augmented generation, RAG models, right? I will not go into the technical details of a RAG model or anything of that nature, but it's basically, you can imagine that the model that you grab from the net or you grab from any third party provider has been trained on a generic data. And let's say I'm running my company, RP Inc., right, or RP Private Limited, and I have tons of data. And this data never went on the internet. So these models don't even have any clue of, what RP Inc. does, or who is RP, or what is their product or services that they're offering, and so on and so forth. So that's where you can say, okay, hey, ChatGPT or Gemini, now I'm giving you this extra 10 files. Each file is 1,000 pages PDF. I'm giving you this extra information. Please digest this information. And while you are answering that, make sure that you answer based on whatever knowledge you are carrying in your foundational model, the prompts that I've given to you, and also what I'm giving is an extra information. So you can see the knowledge which the foundational models were carrying gets transferred to your organization specific knowledge, and that's why it's called the transfer learning as well. So whatever learning it has done, it's able to bring in that. So it's not going to forget that the sun rises in east, for example. It's not going to forget who was the president of US in 2023. It's going to carry all this information, but then it's also going to remember things or know things about RP Inc. now. And that's what the benefit of the RAG is, right? So that's the third level of accuracy. That's what we're looking at. And I'm just also keeping an eye on the time as well. Yeah, I think we are doing okay. Then if you want to make it even more accurate, then you can do what we call as a fine tuning of the model, right? So basically you provide the model an opportunity to learn specific behavior. So for example, if I want to have a model which I'm giving a fact sheet of a mutual fund. Fact sheet is basically, every mutual fund company, and a lot of you might be investing there. So let's say I download the SGFC Balance Advantage Fund fact sheet, right? Similarly, I download ICICI Prudential Nifty Index Fund, right? All of them have a one-pager PDF. It has, things like Sharpe ratio, beta, alpha, the technology or the companies that they are investing in, and so on and so forth, right? So on the basis of that, I wanted to generate a commentary, which will go in as my email to my customers, right? That's where the fine tuning really comes in. So basically you say, I'm providing you this fact sheet and this is how you're supposed to read. And by the way, I'm not giving you just one fact sheet. I'm giving you 100 fact sheet where I'm giving you, this fact sheet, write it in this way. Another fact sheet, write it in this way, depending on which mutual fund company you're looking at. And that's what we mean by the fine tuning of the model. You're providing your own labeled data. So you're saying, this is your input, this is what your output is going to be. And the model says, okay, great, I have learned that behavior. Now you can give me any fact sheet and I will generate the entire commentary for you, which is not possible in any of these things because you haven't told, for this input, what is the desired output that you're looking at. You can control some behavior from the prompt engineering, but not to a large extent. Then the mother of all models is your own custom model. So you, for example, your company is really paranoid about, sharing any information or having anything to do with the AWS or OpenAI or Google or Azure or whatever, right? I mean, your company just doesn't like to talk to any of these models or share any data because it's just security and the compliance and the regulatory environment that you operate in. You can build your own model from the ground up, right? But again, this is very, very expensive process. So we have already spoken about the prompt engineering, which is the art and science, and it's not necessarily that you can become prompt engineer in one day. Just like anything in our life, it takes practice. Over a period of time, you'll become a better prompt writer. And there are a lot of companies which are just doing the prompt writing for you or prompt augmentation. So they will take your semi-optimized prompt and then they will write it very, very crisply for that particular model and the model will love it, right? So now let's talk about some of the challenges of the LLMs as well. So they require a significant amount of computing and energy, as we have spoken about. Very, very difficult for the smaller companies to develop. So basically they are raising what we call as a barrier to entry, right? Not everybody can do it, and people who have the LLM may have a certain competitive advantage, which they can misuse down the road. There is, of course, the ethical and the legal concerns around, what data has been used for training. A lot of artists, writers, poets have come in and say, by the way, I think it has stolen certain information from me, right? But it's very, very hard for either party to prove the other party wrong. But there is, of course, some gray area that you should be aware of. And when you go with a paid package from any of these companies, I definitely know for ChatGPT, OpenAI, if you go with a paid version of that, they are actually protecting you legally. So down the road, if there's any sort of legal issue, they will actually be, be a party to it as well. So now we will talk about the small language models and we'll shift gears. So this is, becoming a very, very hot topic recently in the last few months or quarters, right? I mean, SLMs have come back on the scene and they are like, the smaller models. And when I say smaller models, that means basically the parameters in these models are smaller, right? And they're not very resource intensive. They are very light and efficient, and they can do like you can think about this Pareto principle, right? So the Pareto principle says you need 20% of the resources to do 80% of your things, right? Or you can flip it any which way. Like 20% of your products will generate 80% of your revenue. Similarly, 80% of the work that you are doing using a LLM can be handled by an SLM, right? As it is, without any fine tuning, without any prompt engineering, RAG, and everything else that we have spoken about. Just off the shelf, LLM can do 80% of what you're doing from an LLM, and that too with a lot of benefits, which I'm going to talk about now, right? They are very, very resource conscious, right? I mean, so you are very light on your memory. You don't need to have a humongous PC with 32 GB of RAM and a GPU. You don't need to be on the cloud. You don't need to be running the SLMs while being online. Imagine that, right? So imagine that I have built an app, right, which I'm giving to the farmers in the most rural areas without any internet connectivity in India or anywhere else in the world, right? I mean, not just India, anywhere else, right? There's no internet connectivity. I have created an app which is going to leverage an SLM to do the Q&A. So, for example, the farmer may say that, I have this crop. What are the things that you can suggest in terms of improving my yield? And the SLMs are sitting on their smartphone offline, completely offline. It doesn't need the internet connectivity, and it's able to answer those questions on the fly. So imagine that, like, that sort of assistance. Not even a Siri or any of the Google Assistant can do that job for you. They are more secure because they haven't been trained on a massive amount of data. They have been trained on much more curated data. So they are much more secure. There is less risk of the ethical and the legal issues, and they can be really fantastic for a specific domain and a specific task because they've been trained for those things. And even if they have not been trained, you can take them, you can make them on your, you can customize and make your own SLM out of that, which is going to do exactly what you intend to do, right? So very, very nimble and efficient alternative to LLMs. And this is a comparison between the SLM and the LLMs, or the small, so I think there's a typo here, SLM and LLMs, right? So you can see, and this is subjective. So when I say the number of parameters, I call them less than 10 billion as a small language model, but somebody else may say, no, this is not right. Probably you should be looking at 3 billion as a high watermark for the small language model. So it's really okay. But you get the idea that the number of parameters are going to be significantly small. The size of the model is going to be significantly small. The resource will be lower. The computational power will be lower. The consumption of the power will be lower. The carbon footprint will be much, much lower. All of those things, right? So the number of parameters are, just basically the, a factor higher than the LLMs, right? So maybe exponentially higher factors, or the number of parameters that we're looking at in the LLM. Resource usage, much less compared to the LLMs. Training data, they have been oftenly trained on a much more curated data. So instead of grabbing everything which is there on the internet, when anybody launches a new SLM, they will say, no, I'm going to make it much more clean, much more specific to what I want to do. And it's not really requiring that amount of massive data for training, right? The performance, they are excellent for a specific task, specific domain. LLMs are versatile. So, for example, 4.0 can do image generation, text generation, audio generation, understanding audio, understanding images, like truly multimodal. But the SLM cannot do it for you. Training time is much, much smaller over here, and LLMs definitely require a lot of time and resources. Cost also the same way. This is probably the most important point: deployment. Right? Everybody can access the large language models, but do you really have the hardware to deploy for your clients, for yourself, and use it day in, day out basis? Can you really have that amount of cost? Like, every time you make a query to, let's say, ChatGPT or Gemini, depending on which tier you are in, I mean, there's going to be certain cost that you have to pay, right? So it's never free. There is no free lunch, right? So you have to be thinking about, what sort of resources in terms of the cloud capacity, the compute capacity, the bandwidth, and then of course the cost that you're going to look into, versus the small language model, which can be hosted and they can be completely free. I mean, of course, you have to pay for the bandwidth and everything, but not in terms of the usage, paper use basically. Security wise, they are better than the large language model because of the small surface area that you're looking at, and the amount of data which has gone in and everything. They're much more controlled, so they are better overall. Fine tuning and any of those things that you've spoken about, prompt engineering, RAG, fine tuning, customization, is much easier on the small language model. Again, I mean, I can do a small language fine tuning on my this HP system, but if I ask you to do the fine tuning of, let's say, Llama, 70 billion parameters, good luck. I mean, your system may never come back to you, right? So you just cannot do it, right? I mean, until you have the right hardware. So that's where SLMs score much better than the LLMs, right? And they're ideal for mobile devices, the hardware which are not necessarily having a lot of compute, and also running offline mode. These are some of the examples of the SLMs, right? So you can see Distilbert is having 66 million parameters, so really very, very tiny. I wouldn't use it for lot of customers facing application because I think sometimes too small also is not really good. But you can take a Distilbert or BERT model and then you can fine tune and it may work just fine for you, right? Starting here are some of the real models that you can think about using, and I will demo this Llama model today, and I will ask you to start downloading certain things as well. If you have already done that, if you already know, great, but others may use that time for doing that. But you can see this model from Microsoft 5.2 and 5.3. They're very, very popular, right? And Microsoft has written papers after papers on how 5 models are actually at par compared to some of the bigger models out there, right? And there's a bunch of comparison in terms of different scores and criteria, the type of the content, the quality of the content that these models are generating, and a whole host of other comparative parameters. So bottom line is, I mean, that even with the 2.7 billion parameters, they're doing a phenomenally well job compared to a model which is having 100 billion parameters, right? Or even undisclosed number of parameters. So some of the models don't say that how many parameters I have. They may have upwards of 100 billion parameters. So you can see it's 50 times smaller compared to an LLM, and yet the metrics which they have evaluated will be very comparable, right? So that's basically what we have. So now what I'm going to do is I will give you a demo of how to use the small language model offline using a tool called Olama, right? And before I do that, let me come to your chat window and see if there's any question, comments from anyone so far. Otherwise, we'll start doing the demo. And I will share that link with you people so you can start to download. Actually, let me don't get to the question. Let me just put that link. Sorry, go ahead.
We will take the questions later. Let's continue.
Yeah, correct. So I believe you can still see my screen.
Yes, we can see Olama. Yes.
Okay. So go to Google and type Olama that you see on my screen. Olama. Go ahead and type it in. And click on Olama, the link that you get there. And basically what this is, you have a variety of different models that I've spoken about, both small languages model and the large languages model. So you can see, they have listed out Llama, Gemma, Mistral, 5.3, Mixtral, which is not to be confused with Mistral, and variety of different other models that you can download. So you can see this version of Gamma is basically a 2 billion parameter model. Now this Olama thing you can use in variety of different formats. So you can use it via an API using, let's say, Olama itself as a Python package. You can use via LangChain. You can use via Hugging Face, and many other platforms that you can do, right? But I'm going to show you a way where you can download a model on your local drive and then be completely disconnected from the internet and yet use a model, right? So I'm just going to do basically UI UX demo for you. I'm not going to go the API or the coding path because it's a diverse audience. Some of you may be good at coding, others are learning or don't have any idea at all. So I'm going to make it very, very universal, something which everybody can do without any coding knowledge. And the thing that you're going to do is you're going to click on download button over here, right? So click on the download button and it should start. Basically, it will come to this interface where you have to figure out whether you are using a Mac or Linux or Windows, and it will talk about what specific requirements you have. So, for example, it says I really don't have a lot of expectations. So, as long as you're using a Windows 10 or later, you should be okay. Right. So let's click on the download. I'm going to cancel that anyways once it starts downloading. So you can see this is going to be a fairly big package. So it's 299 MB. Depending on your internet, it may take a while. So I'm going to cancel that. But I will wait for you to confirm that everybody is able to get to this window and you're able to download that. And now I can start to take up your questions as well while you're doing that from your chat. If you have any questions on anything that we have covered.
I think they want to understand how these parameters, you mentioned 22 billion parameters in some cases, 300 million parameters. So I think questions are around that. How this much of parameters are generated and how is it different from LLMs and SLMs?
Yeah. So basically, any sort of large language model or small language models are a specific type of deep learning models, right? And when we talk about the deep learning models, they basically are, you can think about there are many different layers, and deep learning models are, self-trained neural networks. And I'm going in a little bit of a technical jargon over here. And these neural networks are trained using weights and biases. So, for example, you have a certain input and certain output that you're trying to generate. Now, over a period of time, they go through a learning process, right? And they go through certain epochs in terms of, the forward pass and the backward pass, and they will change their weights and biases, which factor is important for predicting what information. So those are the informations which basically get carried on in terms of number of parameters for these neural networks, right? And so they're not just like any other deep learning neural network. They are basically what we call as a transformer. So the GPT, for example, stands for generative pre-trained transformers, right? So they are a specific class of deep learning neural network, and the weights and the biases that those transformers have is basically what we define as a parameter, right? That's more technical, but you can see when you download a model. So when I'm downloading a model, it will download 3.8 GB data for a particular model. When I'm actually going to show you that step, so that's where the parameters are being downloaded. Basically, it's coming in with all the historical knowledge stored in terms of the memory, in terms of the weights and biases, the information it's having. All of that is captured in the number of parameters. Okay, any other questions? So maybe Shinu or somebody else can help me bubble up some of the main questions that people are asking, and then I can address that. And in the meantime, I'm hoping that you are already downloading and you are making progress on it.
Yeah, I think the questions around Olama, what are the small language models? What is Olama itself is a question, but I think they want to know specifically why you have chosen Olama, right?
Yeah. Olama is a tool which will basically make the LLMs accessible for you, right? When I say LLMs, most of them are the free models. So I think in fact everything is a free model over here. So Llama, Gemma, Mistral, Quen, right? So what is happening right now is that a lot of these providers are coming out with their own LLMs, and people are not aware of that. So you can think about it, it's both basically a directory, number one, and number two, it makes it easier for you to tap those models, right? Either via the API access or in a programmatic fashion, or in an offline fashion where you can actually go and start using that model. And once I do the demo, it will become more clear to you. So you can think about it's a tool which helps you access these large language models much more easily. They are not the creators of the large language models. They are the providers of the large language models or small language models. They make it accessible for you. Just like a Hugging Face, it's a directory of different models, different tools that you can use, right? And of course, they will have a certain monetization that they'll be thinking about down the road. But at least I'm not aware of any monetization as of now. Maybe in the API there might be certain things, but as of now, it's sort of like an open source project which intends to make some of these things accessible for you.
Okay, another question is this in terms of NLP, what is the relationship between NLP and LLMs. I tried to provide some answers, but I think you can please.
Yeah, NLP is a specific type of functionalities which the LLMs can do. So, in my view, large language models is a misnomer. And the reason why it's a misnomer is because language itself says that I'm looking at the spoken or written language, right? So that's how we started the whole journey of the large language models. But the large language models now can do much more than languages. They can do actually, images, videos, audios, and whole host of other things. Like, they can actually create the entire movie for you also, right? Or they can actually do the captioning, or they can do the variety of different things that you can imagine, right? I mean, they can write the entire email for you and stuff like that. So they have much more capabilities than just the NLP. So I'll say probably NLP is a small section of things that the large language models can handle. They can do many, many other things.
I think we can do the demo now. I think it is enough time that they would have downloaded.
Everybody has it downloaded?
Yeah, you can just do a thumbs up if you have done.
If you have done the download, just click on the executable file, people, and let it run. And let me know if you have clicked on the, you'll see something like this, Olama setup, for example. Right? If you click on it, then it will ask you to install. And then you can go ahead and do that. I already have installed, so I'm not going to do that. But you have to just go to the section where you have this Olama setup. Click on it, get it installed, and let me know if you're good to go. Then will come the part where you have to actually download a model. We haven't downloaded any model. We have just downloaded the interface of Olama as of now. And while you're doing that, I will just put my LinkedIn in the chat box as well. So you can definitely connect with me offline if you have any questions, thoughts, or it's just good to be connected as well, right? So that's there.
One of the questions which has come now is, does SLM supports multi-model embeddings?
Some of the SLMs may do, but SLMs will not be the right tool for doing a multimodal prediction, in my view. So you have to be looking at typically a big model for doing, a variety of different tasks. So that, like I said, I mean, SLMs are great for compute sensitive, specific task, specific domain sort of application, right? So for example, most of us, we will not say, okay, that I'm gonna do, images, audio, text, marketing, content generation, everything in one go. I mean, so you have a specific use case. Maybe you're working for a bank, right? Maybe all you really care about is, can I give you a PDF? And using that PDF, can you tell me, some of the main points? So for example, if I upload the PDF of a customer's risk profile in terms of the credit bureau, like, CIBIL or FICO, can you tell me, what are the main things that I should be watching out? So instead of me reading, 20 pages of a report or 50 pages of the report, depending on the provider, I can have an LLM do it for me and say, by the way, I mean, I noticed that this customer has a delinquencies, and you can go to page number 6 to find more details on that, right? So it makes your job easier for your day-to-day activities, for your specific domain, for a particular task, not a generic one, in my view. For Mac, you can just go and click on the right one. So when you click on the download, it will give you an option, Mac, Linux, or Windows. Choose the right one depending on your system. And once you have it downloaded, click on the executable file, and it should install the Olama. And I'll wait for you to confirm whether it has installed or not. And the way you're going to tell that is, I'll just get out my command prompt. So you don't necessarily need to go and do it in the Olama interface. I'll just open up my command prompt. I hope everybody knows how to open that. If not, then you can just go in the Windows search and say command prompt, right? When you click on it, you'll see something like this. So basically, it's a command line interface that I'm showing you, which can be run offline. And the first thing I'm going to do is I'll say Olama run Llama 2, right? Now, I already have this model installed on my machine, but if you are doing it for the first time, this will take about 10 minutes because it's going to download 3.8 GB of data. in your C drive. So I'm gonna run it, and you will see. Okay, so I think there's a typo. Let's say, oh, Llama, run Llama 2. So Llama 2 is one of the small language model. I think it's about 7 billion parameters quantized with the 4 bits. So I'm not going to go in the technical details of the quantization, but it basically makes your model much more manageable without losing too much of the information. So now you can see my model is good to go. And this step itself will be people at least 10 minutes of exercise depending on your bandwidth, because you're going to download about 3.8 GB of data if I remember correctly. But in my case, since I've already downloaded this model on my hard drive, I can go and say, tell me how to make Assam tea in 50 words, right? So it's thinking, and because my machine is not really powerful, you can see it's gonna take a little bit of a time. But you can say this is the beauty of running the models offline. So people or organizations which don't want to share anything with anybody outside, I can be running this model completely offline. There's no internet connectivity required. So this model along with all the parameters and everything is basically sitting on my system, and we are actually doing that there, right? So you can see it's just typing out certain things, and I can also show you certain things that you can do in terms of making it better. So right now it's just a bit slow because I don't have a lot of memory available on my machine. So if you have a bigger RAM, like if I were doing this on a Mac, for example, with M2 chip, it would be a lot faster, right? This fairly beaten up Windows system, 3 years old, and yet you can see it's working out okay, not great, but okay. And I think I have taken a decent size Llama model as well. I can also downgrade to a BERT or distal BERT and stuff like that, and you can see it's gonna come out there, right? I can ask any other question, or maybe I'll just tell you how to customize certain things as well. So just give me a moment. So I'll just use this prompt which I have created, and I'm doing this because we're doing the installation. So I'll be more than happy to come back and explain you. So for example, now I can write a prompt. I can set a prompt. Remember I spoke about the prompt engineering. So I'm setting the prompt. So I'm saying, set. So this is the forward slash and set system. So set system is basically telling that you're going to change certain settings in the Olama model. And I'll say talk like a pirate and explain in not more than 50 words. So now it's gonna do a role play. So it's gonna act like a parrot. So if I go and hit enter, so now it will speak like a parrot, right? So for example, I'll say, explain why the sun rises in east. So now it will speak pirate for you, right? So I have already given that prompt, and that prompt is already baked in my model, and it's gonna behave based on that prompt. And I can obviously make that prompt much more specific and all of that, and that's where the prompt engineering really comes in. So we'll not talk about the prompt engineering, but you can see I can control the model behavior as well, and it's definitely speaking the language which we want it to be speaking. So that's what we are looking at. But let me do a sense check where you are in your journey. Are you able to execute the file, folks? This is a very fairly decent system, right? It's not really, I don't know. I mean, I think it's, maybe RAM type of thing, right? So it's really very, very slow. So, and I chose this system on purpose because I have a Mac as well. I wanted to show it on a slow machine as well, that you can see how, even, quite beaten up system can also do certain things. Right, so you can see it has you're still typing certain things because maybe I'm running things and I'm doing certain things. But if I close all my other applications and just have this, it might be a little bit faster. How many of you have the model downloaded completely? Is my voice breaking?
It's fine, Arti. It's fine. It's fine.
Yeah. Ideal. I mean, there's no ideal. Bigger the better, actually. So as long as you have 16 GB RAM, you have some GPU which you can actually give it to the SLM, it will be better for you. Okay, so if you have downloaded the model, I think if everything is executable for you, go to the command prompt and type this. And I'm just gonna send this in the chat window as well. So you have to go ahead and type this command, and that will start the model downloading on your system. And once you've downloaded, you can move forward and you can actually try out. So 4.7 GB, Krishnamurti is saying, okay, so maybe that's the space it's going to occupy for your machine. You can see it's done, and then it will ask for the next thing that you want to ask, and you can ask anything. So right now I'm not giving that prompt, and I will ask something more hypothetical, right? So why are the plants green? Right now, again, it will speak in the pirate style because I've already given that system prompt. So I don't have to always, say, speak in 50 words, speak like a pirate and all of that. It will come back and then again explain me in the that it has understood from this system prompt that we've already set over here. And it will give you a confirmation that yes, I have set the system message for you. No, you don't have to worry about running the Olama. You can just open a command prompt and that should be good. So just go to the search box, depending on your Windows or Mac, just say command prompt and it will work fine on that. You don't need to be using the Olama interface at all. Yeah.
I think one of the question is that SQL data can be trained like this on Olama. SQL data, I think, requires different models.
SQL data meaning you're trying to do the text to SQL.
Structured data like columns to your data tables.
No, you will have to definitely play with this. So it's not going to be a plug and play, right? But it's within the realm of the possibility. So, for example, if you want to have text passed on that my DB name is this, my schema is this, my table is this, write a code to fetch the sales, the profit, and the top selling product, right? You can definitely generate that. But is it going to talk to your databases seamlessly? Probably you need to have the connector and the whole API and the data engineering, data plumbing done. I hope you are able to follow what I've done. And I think the whole beauty is, I really won't disconnect my internet, but you can try it once you have downloaded the model, that you don't need to be actually connected to the internet. So for example, let's say you're traveling, right? And you really got used to interacting with your chat GPT. In fact, you can have this on your mobile phone also, right? And you want to run it offline, that you want to have a Q&A back and forth, and your system really allows that sort of flexibility to you, then you can definitely do it. So that's what basically this will help you do in terms of running the model offline. Or if you're not running the model offline, you can definitely have your model in your S3 bucket or in your on-prem storage, and you can tap the model from there, which is much more controllable, much more easier to get the InfoSec approval from your team compared to a LLM, which is hosted on, let's say, AWS or GCP or Azure, and you don't really know what data is getting passed back and forth between your system and the systems which the LLMs are being hosted, right? So that's the beauty. So I think that's all I had to capture, folks. I know, Shinu had other points to discuss. I have a meeting as well to jump to in the next 5 minutes, but happy to take up any other questions from anyone.
Yeah, I think mostly they want to see how this SLM can be connected to their use cases. One wants to connect to the hackathon projects, another wants to connect to database. So I think how do we mix that, how do we bring that integration?
And those would be the topics that you should be investigating depending on the specific requirements you have. Like I said, all those things that you mentioned are possible, but is it going to be something which is going to be existing on the web that you can search and deploy that right away? Probably not, right? You may have to do certain work on your own, but you definitely have a tool which you can leverage, like with any other LLMs or the SLMs.
I think it's all about experimenting. This is just what is that? It's just a touch and go kind of event. We haven't really wet our feet. RP has done, because most of us were downloading and I think the command line didn't work, or there are so many issues that which came in. So I think the script, I think, can you share that script maybe?
Yeah. So I'll just repeat the step one more time. So you have to go to olama.com download. Click on the download button. Depending on your system, you will click on this. Like, I mean, let's say mine is Windows, right? So I've selected Windows. You'll see this getting downloaded, right? I'm gonna cancel that, but let's say this has been downloaded. It will come down to your like this application, Olama setup. You'll double click on it. It will begin the installation process, right? So once that installation process is done, you don't have to do anything. You have to come to the command prompt, and then you will simply type the command that I've already given you. I think I can copy paste. Yeah. So you can say Olama run Llama 2, or you can say I don't want to run Olama run Llama 2. I want to run Phi3 or Phi3 model from Microsoft, right? You can run that. But because I have already loaded this model, and you can load multiple models. You don't have to be necessarily loading one model. So once you type this in, you will see it will start doing certain things. It will say 1.2 GB downloaded, this much work remaining, and all of that. And once it is done, it will come to this, which says send a message, right? That means it's ready for you. So for example, I can say why is sky blue, and it's doing certain things, and it will start to generate the output for you. So at this point of time, you are all set in terms of your installation process. Make sense?
Yeah. Can they do RAG? Is that the process it follows? Yes.
Yeah. So if you go to the Olama, there are a bunch of commands and stuff like that. You can do RAG here. You can do RAG also in the API as well. Yeah.
Somebody says tell is not recognized. Like you have mentioned, tell me how to make Assamti. Tell is not recognized. Is that correct?
No,
I think it must be. Yeah. Tell is part of the prompt. Yeah, I don't think it does.
There's some challenge. I think you just need to look at it again and try it out.
Yeah. Okay. So I think like RP mentioned, you can connect directly with RP or come to the campus. We have more projects around this going on, and I would. I think I hope everyone got benefit out of at least some awareness about how SLM can be simple to make use of it. Yeah, thank you. I think I'll just take over the screen now.
Yes,
and I would want all of you to please stay back for a few more minutes to see what next. So if you can kind of see, I would definitely want to talk about the university and the department which brings this webinar to you. And RP is one of our favorite mentor. We are a North Bangalore based 50-acre beautiful campus where we house about 15,000 plus students, 2,000 plus faculty, and run various programs. Here, one of the division that which we run is called Reva Academy for Corporate Excellence, where we focus on these kind of projects and project-based learning, and all to improve your careers after you start working. So these programs are mainly for corporates and mainly for working professionals that we run. Students are also welcome if you are interested to do some kind of a cutting edge research in these areas. How do we do this? We have an amazing ecosystem and a support system from organizations as well as industry mentors like RP who is part of the design, delivery, and also the final outcome assessment, etc. And all these things are available in the YouTube channel, which you can check. All the webinars and every event that we conduct is recorded and will be available. It is called Reva University Online under the YouTube. We also have a very thriving social media platforms. I think the chat, our team has put all those links. Please follow us to get more information. Our programs are very, very, very market or industry oriented, and we have a very diverse set of participants and cohorts going through various of our programs, and an excellent ecosystem. It's not just the mentors, but organizations who provides tool support or placement support or project support, multiple ways that we we work with different organizations. We have 4 programs in the master's programs. One thing that which we wanted to talk about this program. We have a 2-year master's program in AI, which is AICTE and UGC approved, but open to people with work experience. So, and this is an end-to-end program that we look at. So, somebody was asking about multimodal AI products and projects. That is what we focus on, and all of these things are lab-based, tool-based, and along with 2 cloud providers. So we use AWS and Azure extensively. So there are global certifications are also inbuilt into this. So whoever is really want to learn more, what you saw, as we mentioned, that a 1-hour webinar is not enough, and especially if you are new. But if you are already using LLM, still there are a lot of provisions for further research and customizing the projects as per your company needs. So you are welcome to explore either our master's programs or short-term programs in AI. And I think that's the best way to learn from the best in the industry, and your marketability, your resume goes up. So the program has 3 global certifications. So it also is included in the master's program. And for any information, please do connect with us. I think our team is on standby. And if you want to know more about our programs, please do visit us. We are a beautiful campus again that we are located in North Bangalore. We have sessions from various industry mentors happening today, tomorrow. So if you are around tomorrow, please do walk in, and we would love to meet you and to answer the rest of the queries, because we don't have so much of time. So we are hoping that if you walk in, you can meet RP tomorrow here in the campus. You can meet various other mentors and have a one-on-one interaction, and also connect with us to see what kind of project. Somebody was asking that, how do I fine-tune, say, structured data queries? Now that requires a lot of, much more detailed understanding. So do come to us, and then we will have definitely some guidance for all of your questions. So with that, I think, Rarpi, it has been amazing. I know those who are very new to LLM, we are hoping that you got some awareness. Those who are already working with LLMs, I hope Olama was a new understanding to you, and I hope this webinar has opened up some of the possibilities for you to work on hands-on. So do continue learn, and that's the only way that we will beat the AI revolution which is happening. So keep learning, and thank you so much for joining today. RP, thank you again. Thank you so much, and let's connect in the next webinar or tomorrow in the campus. Good night, everyone. Thank you.